Picture this: in the vast, unending darkness of space, there are moons that defy everything we thought we knew about the cosmos. Worlds where ice conceals oceans that might host alien life, where volcanoes rage on a scale unimaginable, and where strange markings hint at secrets we've yet to uncover. These aren't just chunks of rock aimlessly orbiting planets. They are enigmatic realms with bizarre behaviors and mysteries that challenge our understanding of what's possible. Today, we're diving into 15 of the most fascinating and puzzling moons in our solar system. Each one has a story to tell, a mystery waiting to be unraveled, clues that might even reshape how we see the universe and our place in it. So get ready, because what lies ahead will take you on a journey through the most mind-bending wonders of space, and by the end, you'll never look up at the night sky the same way again. Now turning to Europa, one of Jupiter's most intriguing moons. Europa is a world unlike any other, encased in a thick shell of ice that holds a tantalizing secret beneath its surface, a vast subsurface ocean. Scientists are captivated by this hidden ocean because it might hold the conditions necessary for life to exist. Despite its freezing temperatures and distance from the sun, Europa has managed to stir up hope for finding extraterrestrial life within our very own solar system. What makes Europa even more fascinating are the reddish streaks that crisscross its icy exterior, like scars etched across a frozen canvas. These streaks are believed to be linked to salts or organic materials pushed up from the moon's interior, hinting at a complex and active world beneath the surface. The possibility of subsurface hydrothermal activity further fuels the idea that Europa could sustain microbial life. Its ability to challenge the traditional notions of what makes a planet or moon habitable has transformed it from a curious icy satellite into one of the most promising candidates in the search for life beyond Earth. Now turning to the mystery of Europa's internal warmth, a phenomenon that has puzzled scientists for decades. Despite being located so far from the Sun, Europa's subsurface ocean remains in a liquid state, a fact that defies the expectations for such a frigid environment. The explanation lies in a process called tidal flexing, driven by the immense gravitational pull from its parent planet, Jupiter. As Europa orbits, it is stretched and compressed by these powerful tidal forces, generating heat through friction deep within its interior. This heat prevents the ocean from freezing solid, creating a dynamic environment that could potentially support life. What makes this even more fascinating is the sheer efficiency of this process, as it produces enough energy to maintain a liquid ocean despite Europa being exposed to temperatures that can plummet to over 200 degrees below freezing. The exact mechanisms behind this heat generation, however, remain a subject of ongoing exploration. Could there be additional factors at play beneath Europa's icy crust? Some scientists speculate that radioactive decay within its core or interactions with Jupiter's intense magnetic field might contribute to this heating effect. Understanding Europa's internal heat source is not just a matter of unraveling its own mysteries, but may also provide insights into how similar processes could influence other icy moons across the solar system. With so much to uncover, Europa continues to stand out as one of the most captivating objects in our celestial neighborhood, holding secrets that could redefine our understanding of planetary science and the potential for life beyond Earth. Moving forward, we arrive at Saturn's enchanting moon, Enceladus, an icy gem that has captivated scientists with its extraordinary features and tantalizing mysteries. Despite its relatively small size, Enceladus has proven to be a powerhouse of intrigue, particularly because of its stunning South Pole eruptions. These towering geysers of water vapor shoot hundreds of miles into space, forming a massive plume that has been studied extensively by probes like Cassini. What makes these geysers truly remarkable is that they contain organic molecules and hints of hydrothermal activity, two crucial ingredients in the recipe for life. As these plumes escape from cracks in the icy surface, often referred to as tiger stripes, they offer a direct window into what lies beneath. The data reveals that Enceladus likely harbors a vast subsurface ocean of salty water, heated by processes deep within its core, creating an environment that could potentially support microbial life. This discovery has sparked intense debates in the scientific community about whether this moon might be home to some of the simplest forms of life. Could tiny microbes be thriving in the darkness of this hidden ocean, drawing energy from hydrothermal vents similar to those found deep in Earth's oceans? Enceladus has quickly risen to the forefront of astrobiology, representing one of the most promising locations to search for extraterrestrial life in our solar system. The mysteries surrounding this icy world remind us just how dynamic and surprising the moons of our celestial family can be, leaving us eager to uncover the truths hidden beneath its frozen crust. Now turning to the fascinating tiger stripes crisscrossing Enceladus' southern hemisphere, these long, parallel fractures are far more than just superficial scars on an icy surface. They are the key to understanding the extraordinary geologic activity of this small yet dynamic moon. Stretching across the South Pole, the tiger stripes act like massive vents, releasing the breathtaking geysers of water vapor that we mentioned earlier. But what causes these stripes to form, and why are they so active? Scientists believe that tidal forces exerted by Saturn's immense gravity play a major role. As Enceladus orbits this gas giant, the relentless gravitational pull causes its icy crust to flex and crack. This flexing generates heat through friction, which not only keeps its subsurface ocean from freezing entirely, but also creates the pressure needed to launch its watery plumes into space. The tiger stripes themselves remain relatively warm compared to the surrounding ice, further hinting at the intense internal processes occurring below. Analyzing these fractures has revealed that they are periodically opening and closing like breathing fissures, allowing material from deeper layers to escape. The water spewing from the tiger stripes is laden with organic compounds and tiny particles of silica, which suggest interactions between water and rock, potential evidence for hydrothermal vents on the ocean floor akin to those found on Earth. These vents on our planet provide energy and nutrients to vibrant ecosystems, raising the tantalizing possibility that similar processes could sustain life in the dark, salty ocean beneath Enceladus' surface. By studying the tiger stripes, we gain not only a glimpse into the moon's present-day activity, but also clues about its history and evolution. This enigmatic feature of Enceladus continues to challenge our understanding of icy moons, drawing us deeper into questions about how life might emerge in the most unexpected corners of the cosmos. Moving forward, we arrive at Ganymede, the colossal giant of moons and a true standout in our solar system. As the largest moon orbiting any planet, Ganymede even surpasses the size of Mercury, making it a world of remarkable proportions. But what truly sets Ganymede apart is its magnetic field, the only moon known to possess one. This unexpected feature has baffled scientists for decades. A magnetic field like Ganymede's is typically associated with planets, not moons, and raises intriguing questions about its internal composition and history. Beneath its icy exterior, Ganymede is believed to have a layered structure, much like Earth. Scientists think its core is metallic, surrounded by rock, and then an expansive mantle of ice. Hidden within this layered arrangement may lie a subsurface ocean, locked beneath a thick crust of solid ice. The possibility of this saltwater ocean has been inferred by observing the moon's magnetic interactions with Jupiter, which suggest the presence of a conductive liquid, potentially water, deep below. If such an ocean exists, it could contain more water than all of Earth's oceans combined. Ganymede's surface itself is a patchwork of mysteries. Some areas are heavily cratered and ancient, while others appear to be younger regions shaped by tectonic forces. This striking contrast hints at a dynamic history, one of shifting crusts and possible resurfacing events. The complexity of Ganymede's geology, combined with its unique magnetic field and potential ocean, challenges our understanding of moons and the conditions needed for life. Could its hidden ocean, much like those of Europa or Enceladus, harbor the ingredients for life? While definitive answers remain elusive, Ganymede continues to inspire curiosity and wonder as we probe its secrets through observations and future missions. Its unique blend of planetary and moon-like features makes Ganymede an essential piece in the puzzle of our solar system's enigmatic worlds. With the next phase of the journey in sight, let's delve into one of the most mesmerizing phenomena on Ganymede, its striking auroras. These shimmering bands of light dancing across the moon's surface are not just visually captivating but scientifically profound. Unlike auroras on Earth, caused by interactions between solar wind and our planet's magnetic field, Ganymede's auroras result from its unique magnetic relationship with Jupiter. As Ganymede orbits within Jupiter's immense magnetic field, the charged particles from Jupiter's magnetosphere collide with Ganymede's atmosphere. This interaction generates the auroras, painting the moon's surroundings with an ethereal glow. But there's more to these glowing lights than meets the eye. By studying the movement and behavior of Ganymede's auroras, scientists discovered subtle oscillations, small shifts in their positioning caused by Jupiter's magnetic field tugging at the moon's own magnetic field. These oscillations hinted at something profound hidden beneath Ganymede's icy crust. To explain this, researchers proposed that a layer of salty, conductive liquid water deep below the surface was influencing the moon's magnetic interactions with Jupiter. Such a subsurface ocean, conducting electric currents and altering the aurora's dynamics, offers stunning evidence of a hidden world beneath Ganymede's frozen shell. These findings not only support the possibility of an ocean, but also highlight the incredible role that auroras play as cosmic detectives, helping us uncover secrets buried far below the surface. What lies within this ocean remains one of the most tantalizing mysteries. Could it harbor the conditions for life, much like Earth's oceans? Ganymede's auroras are thus not just a spectacle of light, but a glowing gateway to understanding the unseen depths of this colossal moon. Every flicker and sway of these lights moves us closer to unraveling the secrets locked within this frozen giant. Now turning to Saturn's moon Titan, we encounter a world that feels both familiar and alien at the same time. Titan is the only moon in our solar system shrouded in a thick, hazy atmosphere, one rich in nitrogen with a touch of methane, creating an environment unlike any other. What makes Titan so fascinating is its surface, eerily reminiscent of Earth's in many ways. It has rivers, lakes, and seas, but instead of water, these liquid bodies are filled with methane and ethane, hydrocarbons that exist here in liquid form thanks to Titan's incredibly low temperatures. Imagine standing on Titan's surface, surrounded by an orange-tinted sky, and seeing rivers of liquid methane gently carving through icy valleys, a scene that feels otherworldly and yet strangely Earth-like. This dense atmosphere also generates a weather system where methane evaporates, forms clouds, and rains back down, completing a cycle similar to the familiar water cycle on Earth. But the real intrigue lies beneath Titan's surface and in its potential for life. Scientists believe that Titan may harbor a subsurface ocean of liquid water, hidden under its icy crust, adding another layer of interest to its already complex nature. On the surface, the presence of organic molecules and chemistry akin to probiotic Earth raises tantalizing questions about whether life could exist here in forms vastly different from what we know. Could Titan's lakes and seas harbor exotic microorganisms adapted to thrive in liquid methane? Could its hidden ocean deep below hold the ingredients for life as we understand it? Titan challenges us to expand our imagination about what forms life could take and where it might arise. Here on this mysterious moon, the familiar collides with the strange, creating a landscape of endless scientific intrigue and unanswered questions that continue to captivate astronomers and astrobiologists alike. With Titan's secrets unfolding, we find ourselves drawn further into the mystery of these enigmatic worlds, each one reshaping our understanding of the universe's potential for hosting life. With the next phase of the journey in sight, let us delve deeper into Titan's perplexing methane cycle, a phenomenon so unique yet eerily similar to Earth's own water cycle. On Titan, methane behaves much like water does on our planet. It evaporates from the surface, forming thick clouds in the dense, orange-tinged atmosphere. These clouds eventually condense, producing methane rain that falls onto the icy ground, carving out rivers and filling lakes and seas in a process that mirrors the hydrological cycle we experience on Earth. However, despite this apparent similarity, Titan holds a mystery that continues to stump scientists. How does it maintain such an abundant supply of methane in its atmosphere? Methane is a molecule that, under the constant bombardment of sunlight and Saturn's radiation, should break down over relatively short periods in astronomical terms. This means that without a mechanism to replenish it, Titan's atmosphere would have lost its methane long ago. Yet it persists. Some scientists speculate that Titan's methane may be replenished by geological processes, such as cryovolcanism volcanoes that erupt not with molten rock but with a slurry of water, ammonia, or methane from the moon's interior. Others suggest that subsurface reservoirs might periodically release methane into the atmosphere. Even more intriguingly, the presence of organic molecules on Titan raises the question of whether unknown biological processes could play a role in sustaining this methane cycle, although this idea remains speculative. Whatever the answer, Titan's methane cycle is a captivating riddle, one that positions this moon as a key target in the search for understanding not just extraterrestrial environments but potentially the conditions for life itself. Moving forward, as we uncover these mysteries, Titan reminds us of the delicate interplay between what we know and what we have yet to discover, inspiring endless curiosity about the unknown mechanisms that govern such a world. Now turning to Io, one of Jupiter's most remarkable moons, and a world unlike any other in our solar system. Io is often referred to as a volcanic powerhouse, and for good reason. Its surface is dotted with hundreds of active volcanoes, making it the most geologically active body we know of. These volcanoes constantly spew sulfur and molten material, creating a landscape that is constantly reshaped by fiery eruptions. The surface is painted in vivid hues of yellow, orange, and red, the result of sulfur compounds deposited by the unrelenting volcanic activity. But what gives Io its explosive nature? The answer lies in an intense process called tidal heating. As Io orbits close to Jupiter, the gas giant's immense gravitational pull combines with the additional tug from two neighboring moons, Europa and Ganymede, creating a relentless gravitational dance. This gravitational interaction stretches and compresses Io's interior, generating immense heat through friction, which fuels the moon's volcanic activity. However, despite understanding the general mechanism, there are still many unanswered questions. For instance, why are some of Io's volcanoes so extraordinarily powerful, capable of producing eruptions that can hurl material hundreds of miles into space? And what drives the peculiar locations of these volcanic hotspots, which do not always align with predictions based on tidal heating models? Scientists are digging deeper into Io's interior structure to uncover these mysteries, but the moon's extreme conditions make it a challenging target for close-up exploration. Io remains an enigmatic world, its fiery nature a stark contrast to the icy moons of our solar system. As we unravel its secrets, it not only helps us understand volcanic processes in extreme environments, but also broadens our perspective on the incredible diversity of our cosmic neighborhood. Moving forward to Neptune's moon Triton, a celestial body that stands out as one of the most enigmatic in our solar system. Triton is unique in many ways, starting with its retrograde orbit. Unlike most moons that orbit in the same direction as their planet's rotation, Triton moves in the opposite direction, suggesting that it was not originally formed alongside Neptune. Instead, scientists believe it was a wandering object from the Kuiper belt, captured by Neptune's gravitational pull long ago. This capture theory also explains Triton's peculiar characteristics, as the process would have likely caused significant disruptions to its original structure and path. But Triton's mysteries do not end there. This icy moon is home to active geysers that spew nitrogen gas into space, a phenomenon that has left scientists both fascinated and puzzled. These plumes, driven by processes beneath Triton's frozen surface, hint at the possibility of a subsurface ocean, an idea that is particularly intriguing when considering the potential for hidden pockets of life. Triton's frigid surface temperatures and dynamic geology make it a world that defies simple classification. Its strange origin story helps us piece together the chaotic nature of planetary formation and the dynamic interactions that shape moons and planets alike. As future missions aim to explore Neptune and its moons, Triton remains a tantalizing target, promising to unlock secrets not just about itself, but about the early days of our solar system and beyond. Now turning to Jupiter's moon Callisto, we encounter a celestial body that appears deceptively simple at first glance, but holds a wealth of mysteries beneath its rugged, cratered surface. Often referred to as a dead world because of its lack of apparent geologic activity, Callisto challenges this label in surprising ways. Its heavily pockmarked surface is a testament to billions of years of cosmic impacts, making it one of the oldest and most heavily cratered objects in our solar system. But beneath this ancient, battered exterior may lie something far more complex, a hidden subsurface ocean. Despite Callisto's seemingly inert surface, scientists have detected a puzzling magnetic field that defies explanation. This magnetic anomaly suggests the presence of a conductive layer beneath the surface, and a subsurface ocean of salty water fits the description perfectly. The idea of an ocean on such a seemingly inactive world raises profound questions. How could such a feature persist on a moon with no clear signs of internal heating or geologic renewal? Theories point to the possibility of residual heat from Callisto's formation or tidal forces exerted by Jupiter and its other moons as potential explanations. Callisto's story is a reminder that even the most ancient and unassuming celestial bodies can harbor fascinating complexities. By studying Callisto, we gain insight into the diverse mechanisms that sustain subsurface oceans and the broader potential for habitability in unexpected places within our solar system. Moving forward, we arrive at Uranus moon Miranda, a celestial oddity that has earned the nickname Frankenstein moon for its peculiar and patchwork-like appearance. Miranda's surface is a chaotic blend of massive canyons, ridges, and mismatched terrains that seem to have been stitched together from different geological eras. Some of these canyons are up to 12 times deeper than the Grand Canyon on Earth, making them some of the most dramatic features in the solar system. Adding to the intrigue, Miranda's jumbled and striated regions hint at a violent geological history, but the exact sequence of events that shaped this moon remains an enigma. Scientists speculate that repeated catastrophic impacts or tidal forces from Uranus could have caused Miranda's surface to be torn apart and reassembled multiple times. What makes this moon even more puzzling is its small size, which raises questions about how such a diminutive body could retain enough internal energy to produce such dramatic geological features. Some theories suggest that intermittent tidal heating, caused by gravitational interactions with Uranus and its other moons, might have temporarily melted parts of Miranda's interior, allowing for the resurfacing events we see evidence of today. Miranda's fragmented and otherworldly landscape reminds us of the incredible power of celestial forces and how even the smallest moons can carry stories of immense violence and transformation. Studying Miranda provides a unique opportunity to uncover clues about the complex and unexpected ways moons evolve in the outer reaches of our solar system. Now turning to Saturn's moon Mimas, often called the Death Star moon, due to its striking resemblance to the iconic space station from science fiction. At first glance, Mimas appears quite unremarkable, with its heavily cratered surface and an enormous impact crater named Herschel dominating its landscape. However, this seemingly simple moon holds a mystery that has baffled scientists. Recent observations have hinted at the possibility of a subsurface ocean hidden beneath its icy crust. What makes this finding so surprising is Mima's small size and lack of significant geological activity, which would typically make it an unlikely candidate to harbor liquid water. The presence of such an ocean would require some form of internal heating, yet Mimas shows no obvious signs of the tidal flexing or radioactive decay that could generate the necessary energy. This conundrum leaves researchers questioning whether we truly understand the conditions under which subsurface oceans can exist. If confirmed, Mimas would challenge long-held assumptions about where liquid water and potentially life might be found beyond Earth. This unassuming little moon reminds us that, in the vast complexity of our solar system, even the most unpretentious worlds can harbor profound secrets waiting to be uncovered. Moving forward, we arrive at Hyperion, one of Saturn's most unusual moons. At first glance, Hyperion looks like no other moon in the solar system, with its spongy, porous surface resembling a giant celestial wasp's nest. Its deeply pitted appearance, filled with countless craters, makes it stand out among the many moons orbiting Saturn. Hyperion's strange, chaotic rotation only adds to its mystique. It tumbles unpredictably in its orbit, making it nearly impossible to predict how it will be oriented at any given time. But the oddities do not stop there. Hyperion is also surprisingly lightweight for its size, with an unusually low density that suggests it is made mostly of ice with only a small amount of rock. This porous structure likely means that Hyperion has a lot of empty space within it, acting almost like a celestial sponge. Scientists have speculated that its bizarre appearance could be the result of countless impacts stripping away loose material, leaving its strange surface and low density behind. Yet, even with these theories, Hyperion refuses to give up all its secrets. Its erratic behavior and mysterious composition continue to puzzle researchers, making it a true outlier that defies easy explanation. Hyperion reminds us of the vast diversity and unexpected wonders that exist in our solar system, where even a moon's shape and rotation can challenge our understanding of how celestial bodies evolve. Now turning to Mars, we encounter its larger moon, Phobos, a tiny yet fascinating world with an irregular, potato-like shape that immediately sets it apart. Despite its small size, Phobos plays a big role in capturing our attention with its peculiar features and mysterious behavior. One of the most striking aspects of Phobos is the network of grooves and cracks that crisscross its surface. These strange markings have puzzled scientists for decades, with theories suggesting that they may result from stress caused by tidal forces exerted by Mars' gravity, or even from the aftermath of ancient collisions with other celestial bodies. What makes Phobos even more intriguing is its slow, spiraling journey towards Mars. Over time, it is inching ever closer to the planet, and in a few tens of millions of years, it is expected to either crash into Mars or break apart and form a ring around it. This gradual descent is a stark reminder of the dynamic and ever-changing nature of our solar system. Adding to the enigma is Phobos' uncertain origin. Some researchers speculate that it may actually be a captured asteroid from the asteroid belt, while others argue it could have formed from debris left over after a massive impact on Mars. Whatever its origins, Phobos remains a celestial puzzle, offering more questions than answers. Its proximity to Mars and these unexplained features make it a prime target for future exploration, keeping it at the forefront of Martian and lunar studies. Moving forward, we arrive at Deimos, the smaller and more distant sibling of Phobos. Unlike Phobos' grooved and cracked surface, Deimos presents us with an unusually smooth and subdued appearance. This lack of prominent features is truly intriguing, as it defies expectations for a moon of its size and origin. Scientists have long speculated about the processes that could have shaped Deimos' surface, with some suggesting that it may be coated in a thick layer of fine, dust-like material known as regolith, which could work to obscure its deeper, rocky features. Deimos' smoothness isn't the only mystery that captivates researchers. Its origins, much like Phobos, remain a subject of active debate. One theory posits that Deimos, along with its sibling, could have been captured from the asteroid belt, a region filled with rocky remnants from the early solar system. Alternatively, some scientists argue that Deimos might have formed from debris created by a massive impact on Mars long ago. What sets Deimos apart is its quiet, stable orbit. While Phobos is spiraling toward Mars, Deimos is calmly drifting further away, as though escaping the planet's grasp. This slow divergence adds yet another layer of intrigue, suggesting differences in their formation or interactions with Mars over time. Though smaller and less dramatic than Phobos, Deimos holds its own mysteries, quietly urging us to uncover more about its past and its role in the story of Mars. Its peculiar characteristics and uncertain origins make it an important piece of the Martian puzzle, and one that future missions may finally shed light upon. Now turning to Amalthea, we find ourselves back at Jupiter, exploring one of its inner moons that stands out with its peculiar characteristics. Amalthea's surface exhibits a striking reddish hue, a feature that has puzzled scientists for years. This coloration is believed to be the result of sulfur compounds from Jupiter's volcanic moon Io, which are deposited onto Amalthea as it orbits within Jupiter's intense radiation belt. But Amalthea's mysteries do not end with its color. Its light and porous structure defies easy classification, leaving astronomers scratching their heads about whether Amalthea should be considered an asteroid that was later captured by Jupiter or a moon that formed from the planet's early material. Amalthea's low density suggests a composition dominated by ice and rocky materials, making it much less dense than other moons of comparable size. This unique makeup has prompted researchers to delve deeper into its origins, as understanding Amalthea could provide vital clues about the conditions in the early solar system and the processes that shaped Jupiter's formation. Adding to its intrigue is Amalthea's proximity to Jupiter, placing it in a region exposed to intense gravitational and radiation forces, yet it has somehow maintained its structure over billions of years. Amalthea isn't just a relic of Jupiter's history, it's a witness to the dramatic forces at play in the planet's vicinity since the dawn of the solar system. As we continue to explore, Amalthea reminds us that even the smallest and most unassuming celestial bodies can hold secrets that deepen our understanding of the universe. Moving forward, Saturn's moon Iapetus takes center stage with its mesmerizing and perplexing two-tone appearance. Imagine a celestial body where one hemisphere gleams brightly with reflective icy surfaces, while the other is cloaked in a dark, coal-like material, creating a visual contrast unlike anything else in the solar system. This stark division has baffled astronomers since it was first observed, raising questions about how such an unusual feature could come to exist. One prevailing theory suggests that material from another moon, possibly Phoebe, a smaller outer moon of Saturn, may be responsible. As Phoebe orbits further from Saturn, it constantly sheds fragments of dark, dusty material, which could be slowly drifting inward and settling on Iapetus' leading hemisphere as it orbits the planet. This would explain why one side appears so dark, as if painted by cosmic dust. But the mystery deepens when we consider how Iapetus' own surface processes might enhance this contrast. Some scientists propose that the darker material absorbs more sunlight, causing the surface to heat up and triggering sublimation, a process where ice transitions directly into vapor. This would leave behind even more of the dark material, reinforcing the stark boundary between the light and dark regions. This feedback loop adds another layer of complexity to an already enigmatic moon. Iapetus isn't just unique in its appearance. Its strange walnut-shaped equatorial ridge, which rises sharply along its middle, further amplifies the intrigue. This ridge has sparked debates about its origin, with ideas ranging from ancient tectonic activity to material left behind from a possible ring system that once surrounded the moon. Iapetus challenges our understanding of planetary science, reminding us how much there is still to uncover about the forces shaping such extraordinary celestial bodies. Now turning to the final stop on our journey through these mysterious moons, we arrive at Charon, the largest of Pluto's companions. At first glance, Charon might seem like a quiet, frozen world, but a closer look reveals an incredibly dynamic and fascinating story. Its surface is carved by deep canyon systems that stretch for hundreds of miles, hinting at a powerful geologic past. One of its most peculiar features is the strange reddish cap at its north pole, which scientists believe is formed by gases escaping from Pluto's thin atmosphere. These gases, primarily methane, are pulled in by Charon's gravity and freeze onto its surface, where they undergo chemical changes triggered by ultraviolet light from the distant sun, producing the reddish hue. Beyond its surface features, Charon's relationship with Pluto is like nothing else in the solar system. The two are so closely matched in size that they orbit a common center of gravity located in the space between them, creating a unique binary system. This gravitational dance locks the two worlds in a synchronized spin, causing the same faces to perpetually face one another. Evidence also suggests that Charon once had subsurface oceans, with its surface fractures possibly caused by the freezing and expansion of water beneath its crust. It is this blend of ancient activity and ongoing interactions with Pluto that makes Charon a captivating subject. While it may mark the end of our list, it leaves us with a powerful reminder of the unexplored wonders that await us in the furthest reaches of our solar system. Now turning to an even closer examination, let's dive deeper into the extraordinary gravitational relationship between Charon and Pluto, often referred to as a binary dance. Unlike most moons that orbit their planets, the gravitational pull between Pluto and Charon is so perfectly balanced that the point around which they orbit lies outside of Pluto itself, a rarity in our solar system. This means that instead of Charon simply circling Pluto, the two celestial bodies revolve around a shared center of gravity, as if they are locked in a cosmic waltz. Adding to the intrigue, this synchronization causes both Pluto and Charon to keep the same face turned towards each other at all times, a phenomenon known as mutual tidal locking. Imagine standing on Pluto and always seeing the same view of Charon in the sky, or standing on Charon with Pluto perpetually looming in the same place. Scientists believe this intricate dance may have begun billions of years ago, likely triggered by a colossal collision that formed the Pluto-Charon system as we see it today. The impact would have blasted material into orbit, which eventually coalesced into Charon, while the gravitational interactions over time slowed their spins and brought them into their current synchronized state. This unique pairing not only challenges traditional ideas of planet-moon relationships, but also provides valuable insights into the early dynamics of our solar system. The mysteries surrounding how this binary system emerged and evolved continue to fascinate astronomers, as studying it could unlock clues about other distant worlds beyond our solar system. With this remarkable partnership between Pluto and Charon, we are reminded of the complex and ever-surprising nature of the cosmos, a relationship that underscores just how much there still is to discover. Moving forward, let's take a moment to reflect on the intriguing common threads that weave through the stories of these 15 mysterious moons. From the icy crust of Europa hiding an ocean beneath, to Enceladus erupting with geysers that hint at hydrothermal vents, the theme of subsurface oceans emerges as a captivating mystery. These hidden oceans could be teeming with organic molecules or even primitive forms of life, challenging our understanding of where life might exist beyond Earth. Then there is the enigma of unexplained geologic activity. Moons like Io with its fiery volcanic landscape or Ganymede with its magnetic field and shifting features showcase a level of dynamism that continues to puzzle scientists. Stranger still are the moons like Triton, where methane rivers and lakes rewrite the rules of planetary science, or Mimas, where a possible hidden ocean defies expectations for such a small, seemingly unremarkable body. And let us not forget the peculiar origins and behaviors of moons like Triton, which was likely captured from the Kuiper belt or Iapetus, with its stark two-tone coloration that evokes more questions than answers. These moons remind us that every celestial body, no matter how small or distant, holds the potential to overturn long-held theories. Studying these natural satellites is not just about understanding the moons themselves, but also about unlocking the broader secrets of our solar system's formation, evolution, and potential for harboring life. Each mystery solved brings us closer to understanding the cosmic processes that shaped our neighborhood in space and may even hold clues to the existence of distant exoplanetary systems. These 15 moons underscore the complexity and beauty of the universe, urging us to keep pushing the boundaries of exploration and discovery. With the next phase of the journey in sight, let's turn our attention to the incredible efforts being made to unravel the mysteries of these enigmatic moons. At the forefront of this quest is the highly anticipated Europa Clipper mission, set to revolutionize our understanding of Europa's potential habitability. This spacecraft will orbit Jupiter and make repeated flybys of Europa, using advanced instruments to probe its icy shell, analyze surface composition, and search for signs of subsurface water. By mapping the moon's surface in unprecedented detail, the mission aims to determine whether Europa's hidden ocean truly holds the conditions necessary for life. Meanwhile, Saturn's enigmatic moon Titan is also the target of a groundbreaking mission called Dragonfly. Dragonfly is an ambitious project that will send a rotorcraft to explore Titan's dense atmosphere and diverse surface, hopping from location to location to study its methane lakes, organic rich dunes, and complex chemical processes. This innovative mission will provide new insights into Titan's ability to support prebiotic chemistry or even exotic forms of life. And while Europa and Titan have dedicated missions, the allure of exploring other mysterious moons has not been forgotten. Discussions are ongoing for future missions that could investigate Enceladus, with its spectacular geysers that may be linked to hydrothermal activity, or Triton, whose retrograde orbit and active surface make it a prime candidate for further study. As technology advances, so do our capabilities to explore these distant worlds. Concepts like autonomous submersibles for probing subsurface oceans or precision landers for sampling icy surfaces are no longer confined to the realm of science fiction. These missions remind us that every leap in exploration brings us closer to answering profound questions about our place in the universe. Are we alone, or is life an inevitable outcome wherever the right conditions exist? The answers may very well be waiting beneath the frozen shells or alien landscapes of these remarkable moons. As the next challenge unfolds, the question that captures humanity's imagination most vividly is this: could life truly exist out there, hidden beneath the icy surfaces of these mysterious moons? Among the most compelling candidates are Europa and Enceladus, where vast subsurface oceans are shielded from the harshness of space by thick icy shells. These oceans are kept liquid by the internal heat generated through tidal flexing, creating conditions that might be strikingly similar to some of Earth's most extreme environments, like hydrothermal vents on the ocean floor. On Earth, these vents teem with life, relying not on sunlight but on chemical energy, suggesting that life on other worlds could thrive in ways vastly different from our own. Organic molecules discovered in the plumes erupting from Enceladus and the potential for similar materials within Europa's reddish streaks offer tantalizing clues that these oceans might harbor the essential ingredients for life. Then there is Titan, a world unlike any other, with its dense atmosphere, methane lakes, and complex organic chemistry. Although its frigid surface temperatures make water-based life unlikely, scientists are intrigued by the possibility of exotic, methane-based life forms that might have evolved under entirely unique conditions. Triton, with its active surface and nitrogen geysers, presents another fascinating possibility. If a subsurface ocean exists beneath Triton's icy crust, it too might provide a haven for life. The implications of discovering even the simplest microorganisms on any of these moons would be staggering. It would confirm that life is not a singular phenomenon confined to Earth, but a more universal occurrence, fundamentally altering our understanding of biology and our place in the cosmos. Such a discovery would raise profound questions. How might life evolve in completely alien environments? Could intelligent civilizations exist elsewhere in the universe? And what does this mean for humanity's future exploration of the stars? These mysterious moons remind us that the answers may lie closer than we ever imagined, concealed beneath their enigmatic surfaces, waiting for us to uncover them. As we conclude our journey through these 15 mysterious moons, it becomes clear that each one presents a story of wonder and unanswered questions. From Europa's hidden ocean and Enceladus' icy geysers to Titan's methane lakes and Triton's nitrogen plumes, these natural satellites challenge everything we thought we knew about our solar system. They invite us to ask profound questions about the origins of life, the nature of habitability, and the possibilities for existence beyond Earth. Each moon, with its unique features and enigmas, serves as a reminder that the cosmos is far from fully understood. As we gaze up at the night sky, it's thrilling to imagine the secrets these moons might still hold, waiting to be uncovered by future explorers. Will they reveal life in forms we've never encountered? Will they teach us new truths about the universe or even about ourselves? The adventure is only beginning, and with every new discovery, we take one step closer to unlocking the mysteries of these distant worlds. Thank you for joining us in exploring these fascinating moons. If you enjoyed this journey, don't forget to like this video, share your thoughts in the comments, and subscribe to our channel for more captivating explorations of space mysteries. Hit the notification bell so you never miss an update, and stay tuned as we continue to delve into the wonders of the universe.